All right, so today in class we talked about section 2-4, our constant of proportionality. I abbreviated that to COP here, so constant of proportionality. This is the constant multiple that relates proportional quantities x and y. It is the value of the ratio y over x and is represented by the letter k. So basically what this means is we're going to start having equations, right? That equation that we're going to base this all off of is y equals kx. The x in this scenario is going to be our independent variable. So it's a variable that's going to cause change to happen. Right? I'm going to multiply this by a number. After I multiply it by a number, we're going to get our answer of y, which is going to be our dependent variable. So our dependent variable changes based off of what happens over on this right-hand side of our equation here. What we're going to focus on mostly today, though, is this k. So the letter k is representing our constant of proportionality. It is a ratio of y over x. So we talked earlier in class this week about how we put y over x for our unit rates when we're solving them. And that's because I was setting you guys up to create your constants of proportionality. What this means, we're going to see a couple of different ways you could solve these problems. First, for our example 1 here, you can have an example where they're just giving you an equation, and they're going to ask you, what is the constant of proportionality? Your answer is literally just going to be whatever number x is being multiplied by. So in this case, because it's 4x here, x is being multiplied by 4, so our constant of proportionality is 4. Now, when we get to example 2 here, this gets a little bit more complicated. So what we're going to do is we're going to try and find that constant of proportionality from a table. Now, sometimes it's going to be a table, sometimes it's going to be a scenario. So for our table here, I gave you the x and the y. So our apples are x, grapes are the y. In order to get my constant of proportionality, I need to put y over x. So I'm going to take 8 because it's my y value, and I'm going to put it on the numerator here. And then I'm going to take 5 because it's my x value, and I'm going to put it on our denominator here. When I have it as set up as 8 over 5, or my y over x, I'm going to divide these two numbers. Right? So I'm going to take 8, and I'm going to divide it by 5. So 5 goes into 8 one time. That's going to be 5. We'll have 3 left over. We'll bring down this 0 here. 5 goes into 30 6 times. So I'm getting a value of 1.6 for my k. Right? So when I divide those two numbers, that's going to be my k. Because it has to be proportional quantities, I'm going to check with everything in my chart. So since I was given 2 different rates, I'm going to check that those rates are proportional. We talked earlier this week about how they have to be equivalent fractions or equivalent ratios. If I look at my 8 over 5 and then to the 16 over 10, this 16 over 10 is just a factor of 2, right? If I multiply 8 times 2, I'm going to get 16. And if I multiply 5 times 2, I'm going to get 10. So chances are when I do this division, I'm going to get 1.6. Okay, so I'm going to put my 16 on the inside, because that's my y value, and my x value is going to go on the outside. So 10 goes into 16 one time, it's going to be 10. When I subtract it, I'll have 6 left over. We'll drop that 0, and 10 goes into 66 times. So I am getting a matching number of that 1.6 here. So these are proportional quantities because I got the same constant of proportionality when I did my ratio of y over x. Now that I have my constant of proportionality, I can write my y equals kx equation for any scenario. So not just for 5 apples or 10 apples, but for 1 apple, 100 apples, 20 apples. I can write an equation that's going to represent all of those scenarios. When I write this equation, I'm going to keep my variables y and x the same. We're going to leave those alone. The only one we're going to change is this k. So if you look over here, right, I left y alone, so I wrote it as y equals 1.6x. I replaced the k here with the 1.6 that we found over here doing that division. So this equation is going to be representative of all of the different variations we can have of apples to grape comparisons. You're going to be doing this tonight for your homework on page 107, and it's going to be questions 7 through 13. Give it a try, trying to write out your equations, and then we'll cover